Hello and welcome to Tribe Topper. In this video, you are going to learn about energy and its various forms. So let me ask you a question before I tell you what is energy. So why do we eat food? To get energy. And why do we need that energy? To do work. So that means we can define energy as simply the capacity to do work, right? Because we need energy to do work. So capacity to do work will be energy. And that's why the unit of energy is also the same as work. So SI unit of energy is also joules. Now, energy exists in various forms. I am sure you all have heard various names of various forms of energy. Might be knowing one is light energy. Then you have heard heat energy, you've heard chemical energy, nuclear energy, and so many energies. But the energies that we need to learn or know about in this chapter is mechanical energy. That means obviously it is related to work because mechanics is something, a word relevant to work. So we will talk about this form of energy, which is mechanical energy. And just to let you know that mechanical energy consists of two forms. One is the potential energy. I'm sure you've heard the name potential energy. And the other form of mechanical energy is kinetic energy, and we are going to discuss both of them in detail. So let's first talk about the potential energy. Let's say we have a wall of height h, and here is a block of mass mg lying here. Now, the weight mg lying here. Now I want to pick this box and just lift it up and keep it here. So when I will keep this box here, that means, of course, what force do I need to apply here? I am going to apply a force equal to the weight of the object, right? So now, what is the potential energy? Basically, whenever we talk of potential energy, it's either we can say the energy due to height or energy due to configuration. So, we can say potential energy is the energy possessed by a body due to its height above the ground or its configuration. When we talk of potential energy due to height above the ground, that is particularly known as gravitational potential energy. So now here I would say to lift this object, some work has been done, right? So there will be work done to lift an object of weight mg, right? Or I can say of mass m, and so the weight would be mg or the force would be mg to a height h. So you must know that whatever work we have done to lift an object of mass m to a height h, it has been done against gravity. And this because gravity is pulling it down and you are lifting it up. So you are doing work against gravity. So this work done gets stored. This work done stores as the gravitational potential energy, GPE, the gravitational potential energy of the body. Now let's find out a mathematical expression for this. So we all know in the previous lecture you've learned about work. So what is work done formula? That is force times the distance. Now force here, how much force do you need to lift up this object? That will be mg, and multiplied with the distance, that's the height through which you are raising. So that is mgh. So we get a simple direct formula for gravitational potential energy, that is mgh, because work that we did against gravity is going to be stored as gravitational potential energy. This is the first formula, and this is a very important formula for gravitational potential energy. The next thing you need to know is kinetic energy. Now, what is kinetic energy? That is basically the energy possessed by a body due to motion, right? So, whenever we have a moving body, it possesses some energy. That energy is kinetic energy. Now, again, we have to find out the kinetic energy from the work done. So we'll say work done to change the speed or velocity of a body from u to v will give us the kinetic energy. So let's find out how are we going to find the work done to move a body and change its velocity from u to v. So suppose we have an object here of mass m and you apply a force F. After moving through some distance s, the block reaches here. So initially it had a velocity u, and when you applied a force, it changed to the velocity v and it traveled a distance s. So what is the work done? Therefore, work done is force times distance, that is Fs here, and force as per Newton's second law we have done is mass into acceleration into s. Now I have the equation for work as MAS, but this is not the expression for kinetic energy. Using the Suvat equations, if you remember, v square minus u square is 2as. We know since v square minus u square is 2as, therefore as is equal to v square minus u square upon 2. So I'm going to plug in this value of as here, and that would give me an expression for work to be what? Therefore, work done becomes mass times as, which is half of v square minus u square. I say let initially the body was at rest. So I'll say let u was 0 because my body was at rest initially. So when you applied a force F, the velocity was gained by the body and it became v. So what will be the work done? That will give me a work done would be half mv square, right? Because it will be half m into v square minus 0. So work done is half mv square. And this work done to move a body or change the speed of the body from 0 to v will be stored as the kinetic energy of the body. Therefore, kinetic energy expression is half mv square. But you have seen whether it is gravitational potential energy or it is kinetic energy, every time it is the work done. So either you lift something against gravity, the work done will be stored as gravitational potential energy, mgh. If you are moving a body, then you are doing work against a frictional force or you are doing a work by the applied force. So in that case, you get the kinetic energy, which is half mv square. So here comes the role of a very important law of it here, which is law of conservation of energy. This law states that, so we say the statement is energy can neither be created nor be destroyed. It can only be transformed from one form to the other form. So that means if I go back to this block, which is lying here at a height h, it has a gravitational potential energy at the top, which is mgh. The moment this box falls down and it reaches the bottom, it hits the earth or the ground with the velocity v. It has lost all its height. So potential energy is 0 now, and it has gained a kinetic energy equal to half mv square. So a very important application for the law of conservation of energy comes out that most of the times which you'll be using in solving all your problems will be that gravitational, we'll say therefore the gravitational potential energy at the top is going to be the kinetic energy at the bottom. But please remember, this will be applicable only when it is given in the question that no energy is lost. Sometimes they will mention no energy is lost directly, or sometimes they will mention that air resistance or drag forces are negligible. So if air resistance is negligible, that automatically tells you that no energy will be lost. So when no energy is lost, the gravitational potential energy at the top should be equal to kinetic energy at the bottom. And so mgh should be equal to half mv square, which means m, we are talking of the same mass, it cancels out. So if you want to find the velocity of an object on hitting the ground, how can you find it out? Simply v square will be 2gh, or v would be root 2gh. That means all you need to know is just the height. So if you know the height, you can find I mean, if you know the height from which the object falls, you can easily find the velocity with which it will hit the ground. Or if you know the velocity with which something is thrown up, then you can find the height up to which it will go, because all the kinetic energy at the bottom will be converted into gravitational potential energy at the top. So you will again end up equating the two energies. So you can find V if you know H, or you can find H if you know V. So this law of conservation of energy is very, very important, and we often use it. So do not forget to apply this law, but only when energy is not lost or air resistance is negligible, because they might ask you sometimes the questions where they also say the kinetic energy at the bottom is not same as the gravitational potential energy at the top. That means in such a case, your gravitational potential energy at the top would be equal to the kinetic energy at the bottom plus the energy that has been lost. So if in the question it is asked, find the energy lost, how can you find that? Simple. Energy lost will be equal to whatever gravitational potential energy existed at the top. From that you subtract the kinetic energy if you know. The energy lost will be found out. Mostly this energy is lost in the form of heat and sound. So I hope this topic of energy and the law of conservation of energy is clear. It is a very important law. So that's all for this session. In the next video session, we are going to talk about a couple of problems based on law of conservation of energy, and also we'll talk about the elastic potential energy. So that's all for this video session. Thank you for watching.